we started discussing about internet related things actually, like how uh, the private or LAN users traffic, how to reach internet, what configurations are mandatory. So every internet router must be configured with static default routing, and we need to define NAT on interfaces like inside and outside, NAT inside and outside configuration. So first thing is static default routing with all zeros, 0.0.0. Traffic can go via 0/0. And we need to define NAT on interfaces. Like inside outside command. And next we can configure PAT and finally ACL rule. So these configurations must be configured on every internet router to reach the LAN users traffic internet, unknown destination. Same setup today also. End devices are connected to switch, switch is connected to router, router connected to ISP, ISP to internet. Let's say ISP name is ACT broadband, and I got 60 Mbps link. So in this router, all configurations, what are the mandatory configurations like static routing, static default routing, NAT, PAT, ACL, like all configurations are done in R1 router. And fundamental rule, based on fundamental rule, router LAN interface IP and use IP address should be in same network. So I configure 10.2, 10.3, 10.4. But main important point is what will be the default gateway IP address for LAN users. What will be the default gateway, guys?
10.0.0.0.
10.0.0.0 is the network ID. We can't use that network ID.
0.1.
0.1.
Yeah, sorry. Yeah.
So default gateway IP address will be 10.0.0.1. Then all LAN users traffic will generate. Will come to router 1, router 1 to ISP, ISP to internet with how much speed they can reach? 60 Mbps. So this is one network setup. Now everything is up and running. But point is, what after some time if ISP got failed? If ISP is down, then users can reach internet?
No.
No. Like your engineering team cannot be access internet. They're connected to internet public servers to download some automation programming. They're running some programming. They're testing in the internet. If internet is down, then no communication. If it's a home network, the downtime can be 2 hours, 4 hours, can be no problem actually. Right? It's a corporate network. If ISP down, then no communication. This point of this type of topology is what we called single point of
Single
failure.
point of failure.
Yes, exactly. Because we have only one service provider. If service provider is down, then no communication. So to eliminate single point of failure, what we require? Backup, backup service provider, backup links. Redundancy we require actually. So what I'm doing is I'm taking one more ISP from MAC for redundancy purpose. Let's say this is ISP1, ISP1 link, and one more link from ACK Fiber. This is ISP2. So why ISP2 required? Why ISP2?
Backup.
Backup purpose. A primary link is ISP1. So ISP2 is only for backup purpose, then I'll go with 16 Mbps speed. It's only for alternate temporary purpose. A primary is ISP1. So all LAN users traffic should go via ISP1. Whenever ISP1 fails, only for alternate, only for temporary, we'll go with ISP2, redundancy purpose. Agree? Yeah. So this type of topology we called redundancy topology. So here we have redundancy for what? ISP redundancy. Now let's understand. All LAN users traffic is going via ISP1. What if ISP1 fails? If ISP1 fails, users can reach internet with ISP2? Yes or no?
Yes, yes.
No. Why? Who is ISP1 service provider? ISP1 name. Who is that
Act.
ISP1 service?
Act.
Act Fiber. Okay. ISP2?
Same.
Yes. See, if ISP1 fails, then what happened to ISP2 automatically?
Same.
Will also
And
fail.
that's what ISP2 also will be fails now. Then how we can reach internet?
Different.
Exactly. So this is a very important point you need to always keep in mind. Whenever you are taking a backup for redundancy, better we need to go with what? Different service provider. It is not advisable for same service providers from two links actually. Okay. Better go with different service provider. BSNL. Yes. Now we have redundancy. The primary is Act Fiber. If his Act files, we can go with the BSNL. Agree? Yeah. But this is not our scenario, guys. Our main topic is what if router fails? ISP is okay. ISP1 fails, ISP2. So we have redundancy for service provider. What about router? If router down, means gateway is failure. Gateway is down. So users can reach internet? No, because no gateway, no NATing, no default routing. Thing is down actually. So to replace the new router and configure with the latest all configurations, again it may take downtime. So we have a redundancy for service providers, but here we don't have redundancy for routers. And how users can reach internet. So we need to maintain redundancy for routers also. Gateway redundancy also important. Got it? So this is the topology. Router redundancy topology. This is ISPA, Act Fiber. ISPB, BSNL. ISPA, Act Fiber. What is the link speed? 60 Mbps. ISPB, BSNL. 16 Mbps. Okay. Now says R1, says R2. Why two service providers? Why two service providers?
Redundancy.
Redundancy. Why two routers? R1, R2.
Redundancy.
Redundancy for what?
To access internet for
No,
users.
redundancy. Redundancy for what? See here, why two ISPs is ISP redundancy.
Yeah.
Here, why two routers?
Gateway redundancy.
Gateway redundancy is very perfect terminology for technical action. Always please remember gateway redundancy or router redundancy. Router 1 fails, immediately traffic can go by router 2 without any downtime. Agree? Yes. So this is our router 1. Let's say traffic is going via router 1. If router 1 fails, then immediately traffic can go via router 2. So means here we have redundancy for router, gateway redundancy. But here we have one challenge, man. Challenge is, as per fundamental rule, computer's IP address should be in same network, 10.3. Already have used 10.1 for router 1, 10.4, 10.2 for router 2. So for PCs, I started with 10.3, 10.4, 10.5. Now our challenge is, what will be the default gateway IP address for these all LAN users now? Yeah. Yes, please. Default gateway, please.
I think it's both 1 and 2.
How we can assign two gateways? No, only one gateway.
There are 2 routers, right?
Two routers are available, but gateways we can assign only one.
Mm.
Does it
We
depend on
can.
the path? Like whichever.
Okay, let's say default gateway is 10.0 dot. That is what our challenge actually now here. See, if I assign gateways 10.0.0.1, then all LAN users traffic will reach internet via which router?
R1.
Router 1,
Router.
R1.
Via router 1 and ISPA internet with how much speed?
60.
60 Mbps. Okay. So we configured gateways 10.1. All LAN users traffic is going via router 1 with ISPA internet with 60 Mbps. Our network is up and running. Our engineering team is connected to internet. They're accessing internet servers. Well and good. But what happened after some time if router 1 fails? Means your 10.1 gateway is down, then users can reach internet?
No.
No.
No. So here we don't have redundancy now. But router available, ISPs are available, but no internet access. Until we change the gateway address. Now if we change default gateway address is 10.2, then all LAN users traffic will go to R2, ISPB, internet with how much speed? 16 Mbps. Again your router 1 is up. Then how we can traffic and reach with internet with 60 Mbps?
Changing gateway?
Changing gateway. So this is our challenge now. Always changing the gateway. Is it really practically possible? There will be hundreds of computers in your network. So to manage this and to provide redundancy, we need to use some protocol, some mechanism we require here actually. Agree? If we configure that protocol, so the protocol will manage everything. So that protocol we call FHRP, first hop redundancy protocol. So first hop redundancy protocol, which are group of protocols which can provide a default gateway redundancy. Let's get to understand. Say these protocols. First hop redundancy protocols are a group of protocols that provide default gateway redundancy protocols. If there is more than one path to the same destination, what are the protocols? FH, first hop redundancy protocol. See, I'm requesting to everyone from day 1 to till end of the session, end of the training, all CCNA full forms, every topic full forms, minimum, that is very minimum, you should remember, guys. If you not remember few things, you just go back your previous sessions and please memorize all these full forms at least. If you memorize these full forms, then by using that full forms, at least we can get understand technical terms also. Okay. So first hop, redundancy protocol. Then you can understand, oh, this is protocol for redundancy purpose. Like that. So there are group of protocols. So which protocols are HSRP, HSRP, hot standby redundancy protocol, hot standby redundancy protocol, or hot standby router protocol. And one more is VRRP, virtual router redundancy protocol. Virtual router redundancy protocol. Is all a redundancy protocol. RP means redundancy protocol. Here also. FHRP, redundancy protocol. And GLBP, gateway load balancing protocol. Gateway load balancing. So these three protocols are designed for what purpose? To provide gateway redundancy only. When we have a multiple routers, traffic will reach out with one router. Whenever the router fails, then automatically within a second, traffic will reach via R2. That will manage with these three protocols. So in CCNA level, we are going to be very clearly discuss about HSRP protocol, and VRRP and GLBP will come in CCNP level actually, because we need to understand some advanced topics before this understanding the VRRP. Let's just try to discuss how HSRP works very clearly. Okay. Now first tell me, what is the problem? What is the challenge of this in this redundancy topology? A challenge is what here?
R1 fails.
Okay.
Manually changing the router config
Manually changing gateway
Okay.
address, right?
gateway. Yeah.
Why? Because we have a multiple gateways. With two gateways, that is what we need to change frequently, like a gateway addresses. That is a challenge. But if we configure HSRP, you know what HSRP is doing is R1, R2, both routers, you are no more two gateways. You're not two routers. I'm combining you and acting like a one virtual router. So HSRP combines multiple physical routers into one virtual router. The problem is you have a two gateways, then users will need to change gateway address. They might be confused. So you are no more two routers. You are only one. You act like a one gateway. You act like a one gateway address. That's all. That HSRP create one virtual router. No router, just we need to assume that virtual router. So for that virtual router, we need to assign IP address. So I have decided virtual router IP address is 10.0.0.123. Now these virtual router IP address information we need to configure in R1, we need to configure in R2. So what is the physical interface IP for R1? 10.0.0.1. Virtual IP address 10.0.0.123.
123.
For R1 fast Ethernet port. For R2 fast Ethernet port IP address is now 10.0.0.123. Then instead of configuring gateways 10.1 or 10.2, for all LAN users, assign default gateways 10.123. If all LAN users gateways 10.123, now traffic will reach internet via which router? Router 1 is 10.123. Router 2 is also 10.123. Then how traffic will reach internet? Via which router traffic will go?
Virtual router.
Where is virtual router? No virtual router. We need to assume that actually. That's all. Ultimately, traffic should go via either R1 or either R2, physical router only, physical setup only. Na? Agree, Aishwarya? Getting my point?
Yes.
Yeah. Then yes. So to forward the traffic, all LAN users traffic to forward the traffic, HSRP will elect two type of routers. One is active router. Another one is standby router. So HSRP works in this model, active and standby. The router which is elected as a active router role is actively forward the traffic. Active router only has to forward the traffic. Then what is the standby router role? Standby router is a backup for active. Whenever active down, standby router will come in the picture and take the role of active and forward the traffic. Getting my point? So HSRP will elect two type of model router, active and standby. Active router, it can be R1, it can be R2. It depends upon the priority actually. I'll tell you that. So the device, the router which is elected as an active router only has to forward the traffic to internet. Then what is the role of standby router? Standby router is backup for active. If active fails, then standby will become active and forward the traffic actually. So in this case, which one is active, which one is a standby? R1 is active or R2 is standby? Or R2 is active, R1 is standby? How? So HSRP active standby router elections will be done based upon priority. The router which has highest priority will be elected as a active. A router which is having second highest priority will be elected as a standby. Let us say router 1 priority is 150 and router 2 priority is 145. Then tell me which one is active and which one is standby.
Fifty will be active.
R1 will be elected as what?
Active.
Active.
Because
R1
highest
will
priority is active. R2 is a
standby.
standby. Now all LAN users traffic will reach internet via which router?
R1.
Active router, which is
Active.
R1. So that is what active router role. Remember, someone will ask you the question in an interview. HSRP active router role, tell me. Your answer is, in HSRP active router role is, it will actively forward the user's traffic. Simple. An active router only has to be forward the traffic. Then what is the role of standby router?
Active goes down, the standby will goes active.
Excellent. So it means it's a backup. Simply you can say it's a backup for which device? I mean, which router?
Router.
Active router. So in simple terms, we can say standby router role is a backup for active. Agree? If active fails, then it will take the role of standby. Standby will take the role of active and forward the traffic. Yeah. So like this, HSRP works. Now it's providing redundancy, gateway redundancy, router redundancy. If router fails, then without no downtime, users are reaching internet. HSRP is a Cisco proprietary protocol. HSRP works in only Cisco vendors. What HSRP will do, it groups multiple physical routers into a single virtual router. And these physical routers will exchange virtual IP address and MAC address. Routers which are grouped together, which is R1, R2 are grouped together, must be assigned the same group number. That group number we can use between 0 to 255. So when router down or link fails, there is second physical device ready to respond the same default gateway address information. Because this default gateway information is available with R1 as well as R2. Now no need to change the default gateway. If R1 fails, no problem because the same default gateway information is available with R2. Traffic will go via R2. Got it? Yeah. So please look into this picture and try to find out Which one will become active and which is a standby? Tell me.
R1 will be active and R2 will be standby.
Why?
See the speed
Uh,
here.
Know the priority, right?
No priority. How we can say active and standby? You can't say, right?
the configurations of the configuration is what do you say?
No, simple matter, Pranav. The thing is, HSRP elections will be done based upon priority.
We don't know.
But
the
here
priority.
I didn't define priority. Then how we can say R1 is active and R2 is standby? No, we can't say actually. Simple answer we
Okay.
can't say because we don't know priority.
Okay.
Let me project these priority values. See, this is a priority now. Now tell me which one is active and which is standby.
It's R1 is the active
R1
and
is
R2 is
active.
the stand.
Now we can say because R1 has highest priority 200, R2 is 150. So R1 is active. Then traffic is going via which router? Data packet.
R1.
R1. What if R1 fails?
It will choose the R2 standby router. The
Yes, please.
elections will be choose the R2, no option for the data package to move the internet.
Naresh, Aishwarya.
Yeah, it moved to on R2.
R2.
If active fails,
Yeah, standby will be.
Bye.
standby router. How standby router will come to know active got failed? Oh, active fails. I want to become active now. How it comes to know it?
After sending multiple packages, and if there is no response, that's how they will know.
Excellent. That mechanism we need to understand. Because we are not a customers. We are engineers. We need to manage this protocol. So we should know protocol mechanism. We are not the end users, right? So end users don't require anything of knowledge on these protocols. Ultimately, end users require what? They need a proper internet connectivity. That's all. But we are engineers. We are a network team. So we should know how the HRP mechanism works. Today, you simply learning about HRP doesn't matter actually. Completely the mechanism of HRP you need to understand. Get it? So here, main point is how standby will come to know active is failed. Oh, active is failed. Now I want to become active. The complete mechanism based on once you configured HSRP, so R1 router and R2 router, both routers will exchange hello packets for every 3 seconds. For every 3 seconds exchange what? Hello packets via LAN. R1 to switch to R2. R2 to switch to R1. So R1, R2 will exchange hello packets for every 3 seconds. Inside the hello packet, R1 priority value, R1 virtual IP address, virtual MAC address, virtual is all the information will send to R2. R2 also will send to R1. Then R1 will understand, oh, I have a highest priority. I'll become active. Then R2 also willing for that. Yes, router 1, you have a 200, but I have 150. So you have a highest, you be active, I'll be backup for you. I'll become a standby. So active standby elections are done based on what? Hello packets. So these hellos exchange is keep alive mechanism for every 3 seconds in the network. Okay. So by exchanging hellos within 3 seconds, elections is done. It will become active. It will become standby. Now traffic is going via active router. If active fails, then Active will send hello packs to standby? No, because it fails. Then standby will wait for 10 seconds. Just very 10 seconds only. In 10 seconds, if it's not receiving hello packet, then standby will understand, oh, basically I'll receive hello packet for every 3 seconds. It's been 10 seconds, I didn't receive any hello packet. Our active might be dead, it's down. Then standby will become active. It will take the role of active and traffic has been forwarded action. So if any one gateway is down, then users can reach internet. What is the downtime? How much time it may taking?
10 seconds.
10 seconds.
Just 10 seconds. So without any user experience, they don't experience network is fail. Oh, router 1 fails. Now we are reaching with router 2. Or router 1 up becomes again we are going router 1. No, they don't know anything, nothing. Without any user experience, they can reach internet. But as a network team, we need to manage this everything actually. This 3 seconds, 10 seconds is default timers. We can minimize, we can reduce the timers timing 10 seconds time also. Okay. Yeah. So this is how exactly HSRP works. So uses multicast messages to communicate priority with other routers. Multicast message means hello packets. Default priority is 100. Router with highest priority will be the active, and second highest priority will be the standby. What if R1 priority, R2 priority both are same priority? Then which one will become active?
The routers, anyone on.
If we configure HRP in R1 first, R1 will become active. Or if you configure HRP in router 2 first, it will become active. First in, first active. That is, if priorities are the same, the first route up becomes the primary. When priority is the same, in this case only. Anyhow, we can configure priority, we can change the priority. You want to make R2, we can make it actually. The default timers, hold timer is 10 seconds, hello timer is 3 seconds. However, you can change also. Hello messages using multicast address by using 224.0.0.2 HRP multicast IP address. Removing of all protocols multicast IP address is very important. Anyone remember RIP multicast IP address? Super, correct. OSPF, yes please, OSPF multicast IP.
10.
OSPF is 5 and 6. EHRP is 10. HSRP? 2. Yeah. Right. What is the role of active router? Active router role. It sends hello packet. Actively forward users traffic. Virtual IP, virtual MAC address will be exchanged. Actually, how this active router works means sends reply for ARP message requested for virtual MAC address. Means initially, for all LAN users, what is the default gateway IP address?
And
123. Let's say PC1 traffic is generated. He is reaching to internet. Means gateway is 123. 123 is available with R1. Available with R2 also, right? So first time a request pack will go to R1 and as well as R2 both. But that request, which router reply will give? Reply will be from active only.
Active.
Standby will not give reply. So active router will give reply. Yes, all LAN users. I am the one router. You come traffic to me. Then all traffic will go via active router actually. That is what. Sends reply for ARP messages request. Sending hello packet actively forward users traffic. Similarly, standby router role. What is standby router role?
Backup.
It's a backup. Backup for which device?
Active
Backup
device.
for active.
That's
Active router.
simple. It's a backup for active. Okay. Next, it will send hellos or not?
Yes.
Yes, it send hello messages. 2 points. Okay. Next. I mean, when active will when standby will become active?
When it doesn't
No
receive
hello message.
hello messages for 10
That
seconds.
is very particular. That's very important technical term actually. See, if someone says, someone reply is, when standby will become active means if active fails. If active fails, of course standby will become active. Agree. But what is the technical terminology there? When standby will become active? Whenever if it's not received, hello
Back.
messages for 10 seconds. There is actual mechanism, agree?
Yeah.
In normal terminology, you can say active fails, standby will become active. Okay, that is okay. But technically, what happening? Whenever it is not, standby will not receive hello packet for 10 seconds, then standby will become a active. You remember these points actually, okay? Standby router, backup for active, sends hello messages. Whenever hellos is not received for 10 seconds, it takes the role of active router. So standby router will not forward the traffic, guys. This is also a very important point. If R1 fails, is the standby will forward the traffic? I mean, active fails, standby router will forward the traffic, is it?
No, it will wait for 10 seconds.
After 10 seconds also, standby router will not forward the traffic, Sudhir.
It will take the role of active router.
Excellent. It will take the role of active router, then traffic is forward. Means ultimately, which router will forward the traffic?
Active.
Active router.
Active only.
Active only.
Yeah. So this is very confusing point. Most of the students will confuse there only. If active fails, standby router will not forward the traffic. Please remember. If active fails, standby will become active, then traffic is forwarded. Agree?
Yes.
So let's see the configuration part. So two routers, R1 and R2. Host name R1. Host name R2. Interface fast Ethernet 0/0. IP address 10.0.0.1. This is physical interface IP. I'm configuring from starting, okay? Yeah, for R2 also. Interface fast Ethernet 0/0. IP address 10.0.0.2. 255.0.0.0. Now let's start HSRP configuration. Standby. Interface, pass Ethernet number, standby, HSRP group number. Standby means this is a command. Standby means hot standby, HSRP actually, okay? Group number. So we are grouping R1, R2, we are combining. For that, we need to define any one group number. The group number can be 0 to 255, any number you can use. But in R1 and R2, both should be same group number. IP space, virtual IP address. See, R1 physical interface IP, R2 physical interface IP, HSRP virtual IP, LAN users IP address, gateway IP address. These all IP addresses must be in same network. Physical interfaces IP address, virtual IP address must be in what? Same network. Okay, that is IP space virtual IP, HSRP group number, priority. Like which router you want to make active, that router should be configured highest priority value. And standby group number, print versions. This is optional commands, not required actually. Leave it. Yeah. So standby group number can use any group number. My example, group number 5. Standby 5 IP space virtual IP 10.0.0.123 as per our example. In R2 also same command. Standby group number 5 IP 10.0.0.123. Next, standby group number 5 priority. You tell me which router you want to make active, R1 or R2?
R1.
R1. So R1 priority is 150. R2. Standby group number 5 priority 145. Done. So by default, physical interfaces, R1 physical interface is shut down. To activate it, no shutdown. R2 also, no shutdown. So now elections will start between R1 and R2. R1, R2 with exchange hello packets. And in HSRP hello packet, so R1 will tell to R2, my virtual IP address is 10.0.0.123 and my group number is 5 and my priority is 150. Then R2 also will compare. Yes, my virtual IP address also same and my group number is same, but my priority is 145. Right, router 1, you have a highest priority. You please become active. I'll be back up for you. That process is happening now actually. Got it? So once the election process done, then we can verify. Let us verification. HSRP elections are done. Show standby brief. Enter. On which interface we configured HRP? Fast Ethernet. What is the group number? 5. How much priority for R1? 150. What is the state of R1? Active. So that active is local. Then which device is a standby? 10.2 is a standby. Then virtual IP is 10.10.0.0.100. Same command. If we check in R2, show standby brief. Router 2 is fast Ethernet. Group number 5. Priority is 145. State is standby. See, it is standby. Active is 10.1. Standby is local router. So now R1 is active. R2 is standby. Then all LAN users traffic will reach internet via R1 router. What after some time R1 fails? See, R1 is down now. Then
R2 become
R2 will become what?
active.
Active.
Active. Then which device is standby?
R1.
R1.
Oh man, R1 down, R1 fails. How it will come active or standby? You're missing logic.
Right?
Huh? Which one?
R2.
R2 is become active now. See,
Active.
R1, R2, two routers.
Mhm.
See this diagram. R1, R2. R1 is active. R2 is what?
Standby.
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 Now question is, if R1 fails, it's down, completely down.
But since it is standby, R2 is a standby, it has to take the charge, right?
No, you forget, man, it is down. How it can say it is standby? It is down. It is failed, complete disaster. It is down actually. Got it?
Yeah, okay.
So means if it is standby means if one is down, it should respond actually. Is it possible to respond?
No.
It's
No.
failed now.
No. Fail.
Then how it respond? Then how you can say it is standby? We can't say. So if R1 fails, now standby become what?
Active.
Active.
Active. My question is now which is a standby?
There is no standby router.
No standby.
No standby. No standby. That's all.
Whichever is deactivate, not active, then
Okay.
come as active, right?
Yeah. So that is a drawback in HSRP. You can say one is if active fails, standby will become active, but for that active, no standby. Got it? Yeah.
Yes.
See here, I remove the link. Means active down. Now standby will become active. See, before showing standby, and we got one log message. Fast Ethernet 0/0 group number 5. Standby 2 will become what? Active. See,
Active.
show standby brief. Now state is active. Then which is device is standby? No standby, unknown. No standby action. It's clear?
So it won't re-elect, right?
Means it is re-electing, but there is no other device, right? For to re-elect the standby.
Yes. Yes.
Yeah, it searches for standby. And finally it found out unknown. No standby for me.
Mm-hmm. Okay.
Yeah. Then what after some time? Your standby become, I mean, the first router is ups. Then
R1 become active and R2 goes to standby mode.
why?
Because
Oh.
R1 is working and R2 is a second priority, right? So it will go to standby.
Yes.
And also it's working.
Yes. So if R1 works up means now R1 will start sending hello packet with 150 priority. So what R2 will do now? Oh, there is one highest priority device in network. I'm 145. So I'll become a standby. It will become active. Agree? Now R1 is up. When it will become, how much time it may take? Actually, it should take how many seconds? 3 seconds only. Now, hello packet timers, right?
Yes.
But because of this port STP elections, blocking state, listening state, learning state, how much time it may take? More than 50 seconds. Because first thing is the switch port should become green. Then elections will start. Right? Remember drawback in STP protocol. Each port wait up to 50 seconds before the transactions will be. To overcome that, what is the alternate feature? Port fast.
Port fast.
Yes, excellent, correct. If already enable port fast in this post, then elections will be simple. 3 seconds will done. That it is importance of port fast now. Yeah. See, router 2 it's become a standby now. Router 1, that state can see initial state speaking means my hello packet I'm spinning. Let us speak. My priority is so and so. My IP address is so and so. Speaking state. Now standby it will become to what?
Active.
Active. Yeah. So like this, HRP protocol will manage everything actually. But HRP works in which vendor devices?
Cisco.
Cisco.
What about for non-Cisco devices? VRRP, simple. Virtual router redundancy protocol. Like how exactly HRP works, same like VRRP also. Only the thing is HRP Cisco proprietary protocol, VRRP is open standard, and router models are HRP works with active and standby, VRRP works with master and backup. Master is similar to active, backup is similar to standby. And elections will be done based upon the priority like HSRP protocol. Highest priority will become as a master, second highest priority will become as a backup. Whenever master down, master failed, stand backup will become a master and forward the traffic. Almost the same mechanism in HRP, VRRP. Clear guys? Yeah. Let us continue with next scenario. Right. R1, R2, R3, R4. 4 routers. Oh, sorry. Scenario is this, guys. Understand this is. There is one office. What is the name of that office? ABC. In office ABC, all over India wide, there might be multiple branches considered. There are hundreds of routers. So R1, R2, R3, R100, hundreds of routers. All of you following me?
Yes.
So this is very important to understand scenario. If you understand scenario, then concept is simple. So office ABC having hundreds of routers. So example, router 1, 2, 3 are 100. To manage these 100 routers, means installation, configuration, maintenance, to manage everything this infrastructure, 100 routers, which team required? System engineering team, cloud engineering team, or network engineering team?
Network.
Network engineers. Network team. A network team also different levels of employees, freshers, experience, like N L1, network level 1 employee. So highest is N L3, N L2, N L1. These are level section. L1 is basic. L3 is highest. Say L3 engineers are 15 members. L2 engineers are 35 members. L1 engineers are 40 members. So total how many engineers, how many team, how many members are in team?
90.
So to manage 100 routers, there are 90 members actually. Okay. These all devices are connected to network. All devices are the part of a network. R1, R2, R3, R4, R100, all routers are in part of the network. Router 1 IP address is 10.1, 10.2, 10.3, 10.100. So point is one of the user is connected to network and from this PC he is trying to log into R1. Tell me how to log into R1. How to log in, man? How to log in? From this PC, you would like to log into router 1. How?
Telnet.
Telnet. So first thing is before Telnet, Telnet should be enabled on routers. Line VTY 0 to 4 or 0 to 10. Like there are how many members in Office ABC? In your team?
90.
90. So 0 to 89. Then 90 sessions will come. But this packet tracer will not support it. But physical devices can support. Password CCNA, login. Done. So this user is trying to log into R1 with Telnet service. Telnet 10.0.0.1. Why it is, oh, sorry. For PC IP is not a set actually. See, 10.0.0.10. It's a PC IP.
Real.
Now if we Telnet 10.0.0.1, what is asking? Is asking password. What is the password, guys? Configured. Password is CCNA.
CCNA.
Now L3 engineer is trying to log into R1. What is the password for L3 team? CCNA.
Team also same.
L2 engine is
CCNA.
L1 engine is for all
CCNA.
90 members. Password is what? CCNA. Then which employee, which user is logged into R1 router? From L1 team, one of the employees log in, or L2 team is login, or L3 team is login. Who log into R1 router? In L2 team, there are 35 members. From 35, which user is logged in? Sam is login, or Naresh is login? Who is login, guys? You don't know. Agree? This is one point actually. Next point is, let's say Naresh is trying to take a control of R1 router. This is outside hacker. He's trying to take a control of router. See, router 1 is asking a password. Now, what is the challenge, Naresh? What is the challenge now? You want to take a control of router 1. Is asking password. What is the challenge now?
That's what password.
Cracking the password. It's
Cracking the
cracking the
password.
password, right?
Yes.
Then you started working. Oh, I want to take a control of router 1. You started password in single character combination. All combinations you started trying. Doesn't work. 2 characters combination. 3 characters combination. 4 character combination. So you have spent for like 2 days, like 30 days. You have 40 days. You have some 100 days or 2 months, 3 months you spent. Ultimately, if you try with the random passwords in multiple combinations, will you get password or not?
Some one day it
Yes.
will work.
Yes, at some point it can be worked out, right?
Yes.
Yes. So there are 2 cases here. One is which user is login and do modifications that we don't know. Because for all 90 members, same credentials. That is also a problem. Because today one of the L2 engineer is login and he changes some modifications in the bandwidth of IP address that may impact on your network. And if you ask you who made these changes, manager, we don't know, we didn't log in. No recorded, no proofs. That is also problem. And one more problem is now your router 1 is secured, but is not high secured. Only task is tracking the password. Simple. So instead of a simple password, we can create a credentials, a separate usernames and passwords for every employee. For 90 members, each user, each employee, we can create a separate credentials. And we can share to each employee. Employee, you have to log into this router 1 with your credentials only. So instead of a simple password, we can create what? Username and password also. So I'll let you show you how to create a username. Username. Example, Vinesh. Password. Win at 2022. Enter. One user is created. Similarly, username. Vidyesh. Password with 2022. Like the list of all 90 members line by line, we can create all usernames and password and we can share to each employee. After creating usernames, now again if you try to log in, before it is asking only password, right? Now if you log in telnet 1001, still is asking password only. Why? Because this is you just created usernames and password, but username and password is not activated. Line VTY024 login command is only to activate password. Login local. Means this database is available in local device only. Login local. Then username and password both will active. That's all. See, now if you try again, telnet 10001. What is asking? Username. Now Naresh, tell me. if you want to take control of router 1, now what is your challenge now?
My username password.
So now your challenge is double, right? Before is
Yes.
only password, but now
No
you need to
username
crack
password.
the proper username and proper password also. Only for password cracking, it may taking 6 months means, and username password means how much time it may take?
Yes. Yes.
1 year. So for every 3 months, we are changing the passwords again. Secured. So which user can log in now to a router 1 is asking username. Which users can log in? The database, the username which is available in router 1, that users only can log in, right? Vinesh and Vidyesh. Both users can log in. Vidyesh with 2022. See, I log in actually. Clear? Yeah. So this all 90 members team usernames where we going to create in router 1. Now entire our employees can log into router 1 or not, guys?
Yes.
Yes. But task is how our network team can log in router 2? Not possible because the database usernames we configured only in router 1. But how to log into router 2? Aishwarya.
We need to
Again, configure in router 2 as well.
So we need to configure same credentials like username and password, 90 members username and passwords in router 2. In router 3. So for Office ABC, how many routers are available?
100.
100.
In each router, in hundreds of routers, we need to configure the same database. Task is simple, no?
Isn't it gonna
Only this one.
update automatically?
It will update, no. Even we don't have any protocol to update automatically. If we configure in one router, replicate in all routers, we don't have that mechanism also. We need to configure in every router manually. Of course, now we have a network automation and all. That we can dump in one device, in centralized device. We can take all centralized dashboard. So if we do in one device, centralized dashboard, it will replicate to all. That is okay. That is network automation. But traditionally, we understand first actually. In every router, we need to configure. Agree? And one more big challenge is here. After a few months, Vinesh is resigned from my office ABC. Then immediately what we need to do? Last working day, what we need to do?
Deactivate the username and password.
We need to deactivate on which
Yes.
routers?
All
The routers not
In all
possible.
100
all
routers.
100.
In day 2, in Vinesh place, someone is joined. Akhilesh is joined. Then what we need to do?
The
Again
username and
assign
password.
In how many routers?
all 100.
This is a big challenge actually.
So quick question.
Multiple users. Yeah, please, Ratnakar.
There are, but when you are assigning 90, 90, 90, where are the 10?
10.
Yeah.
No, 100 routers, 90 members users, I'm telling. Routers are 100. Employees
okay.
are usernames are 90.
Okay, got it. Sorry.
Yeah.
Create a virtual router kind of a thing.
So the good thing is here, if you configure local database, then your routers is safe and secure. That is good, right? Configuring of username and password. Agree? But problem is what? In multiple routers, in multiple usernames, in multiple times, you need to delete, you need to add, and you need to modify. That is a problem actually, big challenge.
Yes.
So what we can do in real networks is instead of configuring the local router, we'll maintain one centralized database. We'll maintain one external server. So you configured these all credentials in one device, not in all routers. -90 -2, 80. Remaining 88 members also configured in this device actually. And we are pointing to every router. Router 2, you're pointing to server. Router 2, router 1, all routers pointed to server. So only now flexibility more. You want to create, you want to add your device in only one server. No need to be multiple times. Remove Vinesh in server, add another user only one time. Got it? Now understand. Consider Vinesh is L2 or L3 engineer. Vidyesh is L1 team. Is a L1 team action. Now Vidyesh is trying to log into R1 router. He do telnet 10.1 and is asking what? Username and password. What is username? Username is Vidyesh. Password with @ actual password is 2022, but may confused. He entered 1999. A request will come to router 1 because he trying to log into router 1, which is 10.1. Then router 1 is pointed to which device? Server. So router 1 will send a request to server. So and so user, so and so password is trying to log in. It will request to server. Now server will implement one mechanism called authentication. Authentication is a method of identifying users with username and password. Now what server will do? Server will check this database. Let me check my database. What is username? Username is Vidyesh. Okay, username is matching. And password is what? With 1999. No, password is not matching. Then server will reply to router 1. No, don't allow him. The wrong credentials. He might be a hacker. Now Vidyesh can come to know, sorry, I entered my wrong credentials is wrong. Actually, he's a authorized actually. He wrongly entered. A second time, first attempt failed. In second attempt, entered 2022. Request will come to R1. R1 will send the request to server. So server implement what? Authentication mechanism. It's checking the database. Oh, username is matching. For that user, password is matching. Yes, server reply. Yes, router 1, you allow him. Then he log into R1 user mode, R1 privilege mode. And he started working with some verification command like show run command, show startup config command, show IP interface brief, all show command. Vidyesh is which level engineer? Level 1. He limited with command section. All privileges will not applicable. But what Vidyesh is doing is he might be internal hacker. Wantonly, he is entering this command. What is that? Erase flash. If flash is erased, IOS is down, then router will down now. It will impact on the network. It is highly dangerous command action. Now when he entered, now router 1 will not execute that command immediately. It will send request to router it will send request to server. Server so and so Vidyesh is trying to enter this command. Can you please check? Then server will implement one more method called authorization. Authorization is a method of identifying what a user can do, what level of permission is given to that user. Level 1 permission, level 1 privilege or level 2 privilege or what? It's a level 1 privilege. Then server will reply to router 1, no. Please deny this command. He cannot be executable. He is a level 1 employee. That command is denied. And he's trying the multiple times. Erase flash. All commands are denying. Then later sometime Vidyesh can come to know, oh my, I am a L1 engineer. This command will not be work. And he's doing his work with no pinging, with checking with some network. Everything is done. He logged out. Remember, guys, this complete action is recorded actually. Everything is recorded. From which device? 10.2 computer, and what is the MAC address of the device? From where he log in, at what date and what time? After login, what actions is done by Vidyesh? In first attempt, he failed because of password wrong credentials. And second attempt, he login successful. After login, what he tried? Show run command. And multiple times he entered show flash. Means wantedly he's trying to erase the flash action. Because of the security server, he not able to execute that command. And he logged out. So this everything is recorded. That is also taken care about by the server we call accounting. So this server name we call AAA server. AAA. Authentication, authorization, accounting.
Cool.
So every user, every employee, all 90 employees must go with these three actions. Then your network is highly secure. And flexibility more. It's just only in one location you create a user. And you want to remove only one time, not in multiple hundreds routers. But for first time, when you're setting the network, you point out all 100 routers, you sync with the server. That we need to configure actually manually for first time. Got it? You can say the centralized database. Like your Active Directory. Anyone knows about Windows servers? ADDS, Active Directory will be there to manage all users traffic, users authentication. In network, we have it replay. Clear everyone? So when we are creating username, Vinesh, Vidyesh, remaining 88 members for each employee, for each user, when we are creating, at the same time we can assign the level privileges. Vinesh, you are level 3, level 2 engineer, full privileges. Your L1, your limited privileges. Like we can configure privileges also. That will come in real scenarios when you come work with the real applications. There you can understand very clearly actually. Got it? Local database authentication is good. Creating 90 usernames in each router. Routers are safe, secured. Username and passwords are created on the device. It provides better security than simple password. Agree? Cost effective, easy to implement it, security solution. Without any firewall and all everything is good actually. But problem is what? Problem is this local database authentication need to be replicated in all networking devices. So 90 users here, 90 users here, 19 hundreds of routers need to be replicated. That is a problem. Then what is a better and scalable solution used?
Replace server.
AAA server. In AAA server, what is the first A?
Authentication.
Authentication. Next A?
Authorization.
Authorization.
Authorization. Next A?
Account.
Accounting. So authentication provides the method of identifying users with usernames and passwords. Authorization is a method of controlling access to users, what a user can do. Level privileges actually. Accounting, everything is actions are recorded action. So for what purpose? Billing, auditing, and network auditing, network reporting purpose. Information is collected and storing in server. Clear? See, where Vidyesh, he wantedly making the router down or not, how we can tell? See, if you entered one time erase flash command, so maybe you're testing how much level your privileges you can able to enter or not. Fine. 2 times, okay, some mistake you entered 2 times, 3 times also. But you have entered 10 times that command. Every day you're logging, every day you're taking 10 times. Every day. Logs are there actually. Then can we tell wantonly he is doing it? Yes or no?
Yes, yes.
Yes. By mistakenly if you do, it will mistakenly be done with 1 or 2 times. But you're doing 10 to 20 times every day. It means you're trying to attack. It is recorded. So in cross question I can ask you, why with Jesh you enter this many times? If you don't have any intention, then why you enter this many times? Agree? So secure, auditing, reporting, billing purpose, it can be used to replace a function. Any doubts? So this is the configuration part. Actually, AAA works with advantages, increased flexibility and controlling of access configuration, scalability. So AAA is a method actually, but protocols are 2 protocols, Radius and TechAX. TechAX is Cisco proprietary protocol. Radius is open standard protocol. This is the difference between TechAX and Radius. Radius is Cisco proprietary protocol. It works under TCP. Encrypt entire communication. Radius UDP. Radius is supported by multiple vendors, means open standard. But Radius encrypts only password. TechAX encrypts entire communication, username, password. After login, that everything is been encrypted. But Radius only password is encrypted. Configuration is this. So this need to be configured in all routers for one time. AAA new model, TechAX server hosts server IP. Means your AAA server IP. What are the IP for this AAA? That IP address we need to point out here actually. And TechAX server key can create one password, any key you can generate. And this can enable, that's all. Got it? Yeah. All right. So it's all about for today. As per our schedules, we completed HSRP and AAA server. So tomorrow we'll continue with what's our topic tomorrow planned as per plan. We're done with remote login protocols, right?
Yes, yes. Yesterday.
Telnet SSH. Yeah. So we'll see VPN and password recovery, iOS backup. Thank you. Have a good day.